Have you ever been sitting in like a massive sports bar or walking through a sprawling college campus, and you just wonder how they keep uncompressed 4K video perfectly synced across screens that are literally miles apart?
Yeah, it's a huge logistical challenge, actually.
Right. Well, welcome to today's deep dive. We are uncovering the invisible high-tech infrastructure that makes those massive flawless video networks possible for you to enjoy. We've got a stack of technical specs from HDTV Supply, specifically looking at a piece of enterprise hardware called the Kramer 675RT HDMI fiber extender.
It's a bit of a mouthful, but a really fascinating piece of tech.
Definitely. And our mission today is to figure out exactly how this thing bends the rules of physics to keep our world connected.
So to really appreciate what this hardware is doing, we first need to look at the fatal flaw of the standard HDMI cable you probably have plugged into the back of your TV right now.
Oh, you mean the typical copper ones?
Exactly, yeah. Traditional copper cables rely on electrical currents, and as that current travels over a distance, it hits electrical resistance. The physical signal actually degrades.
We just call it attenuation, right?
Right, attenuation. So if you try running a standard high-resolution HDMI signal much further than, say, 50 feet, it's just going to start dropping.
Dropping data
Yeah,
completely.
it just fails.
Okay, let's unpack this. Because trying to push a massive 18 gigabit per second, 4K at 60 hertz signal with full 444 color through a long copper cable is, well, it's a lot like trying to push water through a really long garden hose.
Oh, I like that analogy.
Yeah, longer the hose, the more water pressure you lose at the end. But this fiber extender is like teleporting the water instantly using a laser.
That is a great way to look at it, because this Kramer device solves that attenuation problem by taking that heavy electrical signal and converting it entirely into optical data.
So it's literally just light.
Yes. Instead of losing pressure in a hose, it's using a high-powered, perfectly focused laser to silently flash the data at the speed of light with near zero latency.
Wow. And once you ditch the copper and start using light, the rules of distance just completely change. Like looking at these specs, if you run this optical signal over multimode or ON3 fiber, it reaches 3 kilometers.
Which is about 1.8 miles.
Right. But if you switch over to single mode or OS1 fiber, it pushes a staggering 33 kilometers.
Yeah, it's wild.
That's over 20 miles. But wait, hold on. Why does one type of fiber go 10 times further than the other? I mean, isn't light just light?
Well, no, not exactly. The physics here are pretty crucial. See, multi-mode fiber has a slightly wider core, so as the laser travels down the cable, the light actually bounces off the microscopic walls at different angles.
Oh, so it's zigzagging down the tube.
You're right, zigzagging. And over huge distances, those different bouncing paths or modes start to overlap and smear the data, causing errors.
Ah, I see.
But single-mode fiber uses a core so incredibly microscopic that it forces the laser into a single, perfectly straight path.
Got it. No bouncing, so no smearing.
Exactly. And what's fascinating here is how this scales to enterprise applications. When you think about a 20-mile range, you're literally talking about transmitting 4K video across an entire city.
But honestly, why would anyone actually need a 20-mile HDMI cable, though? I mean, you aren't trying to hardwire a gaming console from your house to your friend's house 3 towns over.
Well, think about like a sprawling military base or a massive metropolitan transit hub. You have a highly secure centralized control room that needs to push real-time zero-latency security footage to displays scattered across distinct buildings miles away from each other.
Oh, okay. That makes sense.
Yeah, at that scale, a 20-mile uncompressed reach isn't just a luxury, it's a structural necessity.
All right, I'll buy that. So the physics of shooting light 20 miles is the first hurdle. But what about the communication? Usually my laptop and my monitor take like 3 solid seconds just to negotiate the right screen resolution when they're sitting right next to each other.
Oh, absolutely. We've all been there.
So how do a video server and a display 20 miles apart figure out what to show without timing out?
That negotiation process relies on something called EDID, or Extended Display Identification Data.
EDID.
Yeah. Think of it as the TV's digital ID card that tells the video source exactly what resolutions and frame rates it can handle. Over massive distances, the millisecond delays in transmitting that ID card back and forth can cause standard systems to just crash.
Oh, wow.
To fix this, the Kramer 675RT uses an algorithm called IEDID Pro.
IEDID Pro, so intelligent EDID processing.
Exactly. The algorithm actively processes and caches that ID card locally. So the video source constantly thinks the 20-mile away display is plugged in right next to it.
Ensuring perfectly seamless plug-and-play operation.
Right. And you combine that with a fanless enclosure that lets you cram 3 units into a single one-use server rack space, plus simple LED diagnostic lights, and you have a bulletproof enterprise system.
So it's essentially acting as a highly skilled UN interpreter. The source and the TV don't have to shout across a 20-mile gap to negotiate. The system already knows what both sides need and translates everything instantly so the technology just, disappears,
Leaving you with nothing but a perfect image.
which is the ultimate goal.
Yeah.
Now, at around the $1,352, this hardware isn't something you're going to buy for your own living room,
Definitely not.
but it is the invisible backbone powering the screens you rely on in your daily world.
It really is. It's the hidden infrastructure making modern life possible.
Absolutely. And it leaves you with an interesting question to mull over. As our video files get heavier and heavier with 8K and beyond, pulling more and more data, how long until this kind of enterprise-level fiber optic conversion is the only way to wire our own homes?
That's a great question.
Will there come a day when the traditional copper HDMI cable goes completely extinct? We'll leave you to think about that.